Okay, so let's look where we're filling the tile map, because maybe we didn't put the correct. Maybe when we constructed the tile map, we did not create this UINT-A array correctly. So we have this map length, and that's the width times the height times the number of components. So that should be correct, right? The reason why I'm thinking that is because, like, maybe if we made this length too big. Oh, sorry. Maybe if we made this length too big when we were creating the tile map, then when we went to go fill the tile map, if we added too many bytes, right, that would create this effect of, we have data and then all of a sudden there's like nothing there. But when we look at the map width, height, and number of components, right, we're multiplying it all together. That looks correct. And then we have the new UINT-A array. So I'm pretty sure that that's good. I don't think that is the problem. I think it's something in that mapping function. So mapping. Okay, so let's think about the mapping. Okay, so now that I think about it, we're mapping to like here on the viewport, but we're taking from over here, and no, we're taking from down here. But our data set is 512 by 512, and when we scale this by 10, so 480, this is 560, so that's off the edge. Our viewport is off the edge of the data set. So our sampler, so actually all the code might actually be correct. It's just that we are sampling from an area that is outside of the bounds of the data set. So right here, because the reason why we have this white is just because this is sampling out of bounds, and I guess what we're getting is just white when we sample out of bounds. So we're like on the edge of the data set. And does that make sense? So red, green, and blue. So we did green for the y-axis, right? So since we did green for the y-axis, and this would be the bottom edge of the data set, green would be full intensity. So yeah, that actually looks correct. It's just that our viewport is on the data set is it's not. We should snap our viewport 1. We need to snap viewport 1 to the entire data set, and then we should see kind of like a zoomed out view of the data set. So let's go to where the do mapping is. And so here's our do mapping, and we have the VP1 right here. And let's just change the viewport, right? Let's just say rectangle pack.rec VP1. Oh, sorry, you can't see this. So right here, viewport 1, we're going to change that. So dot x0 equals 0. So we're going to start at the beginning of the tile map that we're sampling from, and then vp1 dot y0, we're going to start at 0 as well. And we know that it's a 512 by 512 bitmap, or tile map. So we're just going to say 512 minus 1 over here to get all of it. So 512 and then minus 1. And this is viewport 1, right? Because we decided earlier that viewport 0 is always going to be the destination. And then we're just going to say viewport 1 is always the viewport that's sampling the tile map data that's off screen. So if we take that and then we look at our screen and we refresh, much better, much better. Though, is that the correct pattern? Okay, so I'm a little thrown off because the background pattern and this pattern are the same, and it's because I use the same. I tend to use that algorithm a lot, so I probably just rewrote it. and that's why you're seeing the same pattern. And let's have a little sanity check, though. Let's go back into our code where we are. Hold on. So going back into our code, where we're making that fill pattern, the fill tile map with test pattern. Let's change up that pattern a bit to something different, just so that I have a sanity check to make sure that I'm getting what I think I'm getting. What would be an interesting pattern that so I think one way to, let's try to do like let's try to stretch out the color mapping rather than wrapping this color mapping. I think we should try to stretch it out. And so something like percentages. So the percentage X equals, and then it's going to be the position X, which is scanning along the whole thing. So it's going to be px over the width, right? And then we can do this tile map width, and then the percentage y along path is going to be py over the map height, percentage x, percentage y, and then we will so times 255, right? So if you're 100% on the other side of the bitmap or the tile map, we're going to use a full intensity pixel, and it's going to be a solid gradient. And then because we're using kind of like floating point math here, we're going to have to floor these values after we're done using it. So just say times 255, and we could actually leave this blue here, right? So we got a little bit of variety going here. So I will math.floor these two. And percentages, blah, 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 that looks about right. Let's go over here, and let's refresh. Okay, so we got something different. But I gotta say, these diagonal lines are because we're adding the this x and y, right? So that's kind of why we're getting the diagonal gradient. For example, if I just put, I can prove that, right? So if I put 255 here, comment that out, and we go back, right? We're not gonna see any diagonals. So let's refresh, right? So now we see kind of like this pretty little thing here. What do I want to stick with? I think this is a little bit easier to understand because, like, when you look at it, you can kind of tell where everything is. Or alternately, we could just make this 0, right? So we got the red green kind of thing going, like that. That seems easy for me to understand, right? Because you got the black here now, and now you know that's 0, 0, and then you have the full intensity yellow, which you know is 255, 255. So you know where the extreme origins are. So we know that this viewport right here is zoomed out onto the entire data set in memory. Green and red making yellow has always confused me, though, so maybe I want to use like blue and red to get a violet, because that's more comprehensible for me. Or we could use green. We could use green and blue to get a cyan. I feel like green and blue to get cyan. Then again, well, red and blue is hot and cold, whereas green is kind of like a neutral, like when we're talking about warm and cool colors. So I feel like going with that traditional red versus blue might be the way to go. So let's I know I'm kind of weirdly picky with things sometimes. So let's say, so let's do a red versus blue kind of thing going here. We'll make the green 0. And going back here, we'll refresh that, see what we got. Okay, so full intensity on the x-axis, full intensity on the y-axis, and then both colors. But that also is kind of unconventional, right? Because now the order of the channels no longer kind of lines up anymore. Right, because like when you're looking, if you're ever looking at like OpenGL shader code, right, it does the red-green gradient. So maybe you want to stick with that, just because that's kind of a convention. Just can't make up my mind here. Okay, we'll just stick with that, just because that's more conventional. Yeah, we'll stick with that. That's fine. Okay, so now we have something where we can like zoom in and out of a data set. And can we prove that? Yes, we can. Let me stop recording and record again.